Hello students, in NEET 2017 today I will take the 5 questions from 11 to 15. Question number 11 to 15. So now question number 11. Two rods A and B of different material. Two rods A and B of different materials are welded together as shown in figure. As shown in figure. Their thermal conductivities are thermal conductivities are K1 and K2. The thermal conductivity of the composite rod, the thermal conductivity of the composite rod will be. Now we have the options. First I will tell you that what is the figure. This is given here. This is the A and this is now B. Its thermal conductivity K1, this is now your K2. Now this is like this. This is like this. And what is given that here the temperature is T1, here the temperature is T2, and the distance between the length of these. Now options are, first is K1 plus K2 upon 2. Second is 3 K1 plus K2 upon 2. Third option is K1 plus K2, and fourth option is 2 K1 plus K2. These are the options. Now the solution of this one. Now in thermal conduction, you have studied that when the two rods are joined in parallel to each other. So this is the parallel combination of the two rods. Parallel combination of two rods. The thermal conductivity K is equal to K1 A1 plus K2 A2 upon K1 plus K2. This is the formula. And we know that this whole of the area is being divided into two equal parts. This is the length of the rod, this is now D. So here we have A1 equal to A2 equal to A by 2. Now then apply to this. So this K, this is now K1 A1 A upon 2 plus K2 A upon 2 upon A upon 2 plus A upon 2. So what we have? This K equal to K1 plus K2 upon 2. So our answer must be what? The first one. Answer. The right choice is the first choice. So this is the answer to this question number 11. Now the question number 12. The diagram below shows regions of equipotentials. And this region that this is given in the figure. This is now your 20 volt. This is now 40 volt. And now we are having this point A. This is now point B. Now then we are having now here this is the point A, this is now point B, this is your 20 volt, this is 40 volt. And then we are having this is your 10 volt, this is now your 30 volt, this is point A, this is the point B. And now fourth one is like this. Now here is your 20 volt, this is 40 volt, this is now point A, this is now your point B. So this is what the figure A, this is B, this is now C, this is now D. So a positive charge A, positive charge is moved from A to B in each diagram. Now the options are, first option is maximum work is required. Maximum work is required to move Q. In figure C. Second option, in all four cases, the work done is the same. The work done is the same. And third, minimum work is required. Is required to move Q in figure A. And now fourth code, maximum work is required to move Q in figure B. So this is the question. You are given the regions of equipotentials. This is now 10, this is now 20, then this is now 40, this is 20, this is now 40, this is 10 to this is now 30, this is 20 to 40. And the Q charge is moved from the point A to B in this all these figures. So now we have to find the solution of this one. The work done W equal to Q into delta V. Now we see that the delta V in each, this is now 20 volt, this is now 40 to 20, this is now 20 volt, this is 20 volt, this is 20 volt, this is 20 volt. So delta V here, delta V equal to 20 volt in each figure. So what we have, W is the same as W is same. It means that in all the figures, the work done to move the charge Q will be the same. So we have the right options is your second one. In all cases, the work done is the same. This is not right one. So our right answer is second answer. Second. So this is now question number 12. And whatever, when we are given the equipotentials or we are given the 2.2 points where the potentials are given to you, and you find that what is the difference in the potentials. If the potentials at all between the 2 points is the same, then same work done will be required to be done. But if the delta V is not the same, then work done will not be the equal. So this is what the answer of the question number 12. Now question number 13. Question number 13. Now question number 13, the ratio of wavelength. The ratio of wavelength of last line of Balmer series. Of last line of Balmer series Balmer series. And the last line of Lyman series. And last line of Lyman series is now the option. First is 2, second is 1, and third 4, and fifth is now 0.5. So now we have to find the solution. What is this solution? Now you must know the formula of Balmer series and that of the Lyman series. So for Balmer series, 1 upon lambda equal to R into 1 by 4 minus 1 upon n2 square, where this n2 equal to 3, 4, 5, 6 and so on. So last line for Balmer series we are taking, so this is now u1 upon lambda b. So 1 upon lambda b infinity, this is equal to R into 1 by 4 minus 1 upon infinity. So what we have? This is R upon 4, or this lambda b infinity, this is equal to 4 upon R. Now for Lyman series, this 1 upon lambda is equal to R into 1 minus 1 upon n2 square. Lyman series, this is now suppose L. So now we have the last line, 1 upon lambda L infinity, this is R into 1 minus 1 upon infinity. So this 1 upon lambda L infinity, this is equal to R, or this lambda L infinity, this is equal to 1 upon R. So now you find the ratio. So lambda b infinity upon lambda L infinity, this is now your 4 upon R, and this is your 1 upon R. R and R will cancel, so you will get it to be 4. So now the ratio between the of the last line of Balmer series and that of Lyman series, that will be equal to 4. So now we have the right option is 4. So our answer is 4 means it's not third one. It's not third answer. So what is that? This is a direct application of the Lyman series and the Balmer series. You must know the formula and then find it the wavelength for the last line. Last line means the value of n2, that will be equal to infinity. So this is the answer to the 13th question. Now we have the 14th question. So I have told you earlier also that whenever we want to find out the solution of a question in the NEET paper, you should have the intrinsic knowledge of the subject. Now question number 14. And 14. Now we have Young's double slit experiment. Young's double slit experiment is first performed is performed in air and then in a medium. And then in a medium. In a medium other than air. Other than air. It is found that it is found that eighth bright fringe in medium lies where fifth dark fringe lies in air. The refractive index of medium. The refractive index of medium is nearly. Now option first is your 1.25, second is 1.59, third is 1.69 and fourth is 1.78. This is the question. So you are given that it is found that the eighth bright fringe in the medium, eighth bright fringe in the medium lies where the fifth dark fringe lies in the air. So first we take the for bright fringe. Bright fringe. Now we have the path difference. Delta is equal to n lambda dash, because this is being performed in the medium, 8 in the medium. So this is now your 8 and this is now lambda dash. This is now for what? The bright fringe in the medium. Then for dark fringe, delta dash. This is not suppose delta dash, this is not delta. Then this is what? The fifth dark fringe. So this is now your 2n minus 1 into lambda by 2. Now here n is equal to 5. You are given the fifth. So this will be your 9 lambda upon 2. These are 2 lambda. Because this fringe lies on this one, it means the path difference between them must be equal. So according to question, now this delta equal to delta dash. So delta is how much? 9 lambda upon 2 and this is your 8 lambda dash. So this lambda upon lambda dash equal to 16 upon 9. Lambda upon lambda dash, this is now value of mu. So this gives you mu. equal to, now this is 1.78. Lambda upon lambda dash is equal to mu, the refractive index. So now our answer comes out only now this fourth one. So our answer is fourth. This is the correct choice. So what we have, you have to understand that the 8th bright fringe in the medium lies where the 5th dark fringe in air. So both these coincide. It means the path reference between the two must be the equal. So then you have to apply this formula and then equalize them and find the mu, the refractive index. And now the last 15th question. Question. A particle executes linear simple harmonic motion with a amplitude of 3 centimeter, with a amplitude of 3 centimeter. When particle is at 2 centimeter, when particle is at 2 centimeter from mean position, the magnitude of its velocity, the magnitude of its velocity is equal to its acceleration. Then its time period. In seconds. Is now the option. Now first option is √5 upon pi. Second option is √5 upon 2 pi. And third option is 4 pi upon √5. And fourth option is your 2 pi upon √3. This is now question. Now the solution. You are given a simple harmonic motion, and this is given that the magnitude of velocity at distance 2 centimeter from the mean position is equal to its acceleration. So what we have, the velocity v equal to omega square root of a square minus x square, and acceleration Now magnitude of these two is equal. So what we are able to take the magnitude to this one, then this minus sign will cancel, and this now magnitude. So these are equal. What is given? That according to question, what we have, this B magnitude equal to alpha magnitude. So now let us have this omega into square root of a square minus x square equal to omega square x. So now this omega will cancel. So now a is given to you 3 centimeter and x is given to you 2 centimeter. So now you put these values, then this a is equal to 3, so this is now 9 minus 4 equal to, this is now 2 pi upon t, now this is now 2, x is equal to 2. So what we have, or t equal to, this is now 4 pi, this is now root 5, 4 pi upon root 5. It means what? The third option is correct. So one answer is third. This is also a direct application of the simple harmonic motion. You must know the equations of the velocity and that of the acceleration and equalize them and find the time period. So this is clearly given that the amplitude is so much, displacement is so much, magnitude of the velocity and the acceleration are the equal at this distance, then you find the acceleration. This is the time period. So this is today's 5 questions of NEET 2017. Thank you.